Today we're going to start with a warm-up. List the first 10 perfect squares and their roots. You should be pretty familiar with these. We've been working with them now for a while. The squares are 1, 4, 9, 16, 25, and it continues. And their roots are the individual numbers. So 1, 2, 3, 4, 5, all the way to 10. Today we are going to be working with squares. Excuse me. Sorry about that. And so the more familiar you are with your squares, the easier today is going to be. Okay? Even if you don't know them by heart, we now have a list of a lot of them. Today we're moving on to 10.2, simplifying radical expressions. So we're going to start with an example. The square root of 36. 36 is a perfect square, right? So the square root is 6 because 6 times 6 is 36. However, even if you don't know that, you can break it down and end up with that. Today we're going to be given square roots of numbers that aren't perfect squares, and you're going to have to break them down similarly. So 36, the factors of 36, there's a lot of different ones, but off the top of my head, I know that 4 times 9 equals 36. So let's pretend I forgot that I know it's a perfect square. So 4 and 9, when multiplied, equals 36. If I separate those, the square root of 4 times the square root of 9, I know that the square root of 4 is 2. So I separated them here. And I know that the square root of 9 is 3. And 2 times 3 is 6. We're going to be doing that today. Okay? Let's say we have 24. Let's find the square root of 24. So starting with some factors of 24, maybe I pick 4 times 6. I tend to start with 4 because I know it's a perfect square and I know it goes into a lot of numbers. You don't have to start with 4, okay? So the square root of 4 times the square root of 6. The square root of 4 is 2 times the square root of 6 is not a perfect square. So my answer is 2 root 6. If I had chose maybe 8 times 3. Okay. I know that 8 is 2 times 4, and then I still have times 3, right? I can break up 8 into 2 times 4, and I know that if I break that up, I have the square root of 2 times the square root of 4 times the square root of 3. The square root of 4 is 2 times the square root of 2 times the square root of 3, which is 2 times the square root of 6. Okay? How about you try one? How about you find the square root of 80? Okay? I'll do it quiet. All right, let's go over some more examples of problems you'll be doing. Let's say we have a number on the outside with our root. So 3 and then root 16. There's no sign, so it means multiply, right? So we would take 3 times the square root of 16, which we could say 8 times 2. I mean, hopefully we know it's 4, but 8 times 2. And then 8 can be broken up into 4 times 2 times, and then the initial 2, which means we would have 3 times 2 on the outside, and then the square root of 2 times 2, which means 3 times 2 times 2. So 3 times 4 is 12 as our final answer. Let's do one more like that. Let's say we have 2 times the square root of 25. The square root of 25 is 5, so we have 2 times 5. It's much easier if you identify that it is a perfect square. However, if you don't, you just solve it. You're looking for pairs to move out of the root. All right, let's continue. Another type of problem you'll see is multiplying 2 sets. Can you see okay? I'm gonna get a new piece of paper. All right, so let's say we have the square root of 10 times the square root of 14, okay? So if we find or break them up into the the factors, right? So 10 is 2 times 5 times the square root of 14, which is 2 times the square root of 7. So these are all the factors, right? This way we can combine any doubles, right? So the square root of 2 times 2 is 4. And then we would still have the square root of 5 and the square root of 7. Okay, but we combined the doubles, right? It was a repeat. And the square root of 4 is 2. And then we're left with 35. 5 and 7, those cannot be rooted. They're not a square. Okay. Let's do another one like that. Let's say you have the square root of 3 times the square root of 18. Did you get 3 times the square root of 6? So we started with the square root of 3. I broke up 18 into 9 and 2. The square root of 9 is 3, right? If we divide it up, we're looking for 2 of them to multiply, right? And then what's left is what stays in your root. So 3 and 2 are left. Another type of problem that you'll see is a combination of numbers and variables. Okay, so let's go over some like that. If we have 60 x to the 4th, y to the 7th, we're first going to have to break up 60. So I know 4 goes into it. I think it's 4 times 15. And then if I square root x to the 4th, we did this in the beginning of the year, then I'm left with x squared. And then if I square root y to the 7th, it doesn't quite work that way. I have to break it up, right? So I'm going to do y to the 4th times the square root of y to the 3rd, right, to break up my 7. With my numbers, the square root of 4 is 2, and 15 is not a perfect square. So I have 2 square root 15 x squared, and then y squared, right, the square root here. And then here I can divide this up into y squared and y, just the square root of y. Y squared, square rooted, is 1y. So when I rewrite that, I have 2 times the square root of 15 times x squared times y squared times 1y, that takes care of this, times the square root of y. From here, I can combine all my outsides and all my insides. So I'm going to say 2x squared y to the 3rd root 15y. Okay. All right, you try one like this. Let's say you've got 88m to the 3rd p squared r to the 5th. All square rooted. I'm going to work on it quietly while you try it. Okay, when you break it up, you should end up with a 2mp r squared on the outside of your root, and what's left inside is a 22mr. The last type of problem you're going to see today has fractions. So let's say we have 5 over 32 square root. You can't have a square root in the denominator. So the first thing I do is multiply the whole thing by whatever the denominator is. So that means the square root of 32 times the square root of 32 is just 32. Right? If we picked a small number like the square root of 2 times the square root of 2, that is the square root of 4, which is 2. Right? So you just get what you started with. And then on the top, I have the square root of 160, which can be simplified. Okay, so if I take 160, that's going to look like maybe the square root of 16 times the square root of 10. I know that 16 is a square. So the square root is going to be 4 times the square root of 10 over 32. 4 and 32 have common factors. 4 goes into itself once, and 4 goes into 32 8 times. These can be reduced since they're on the outside. So I'm left with the square root of 10 over 8. I'm gonna have you guys try one like this. Let's say we have the square root of 3/4 times the square root of 4/5. So what I would do is the square root of 3 over the square root of 4 times the square root of 4 over the square root of 5. These cancel out, right? They're just like fractions. So the square root of 4 is 2, right? And 2 over 2 cancels out. And we're left with the square root of 3 over the square root of 5. And this is not a simplified answer because there is a root in the denominator. So I'm going to multiply everything by the square root of 5 to get rid of that square root. So I end up with 5 in the denominator, right? The square root of 5 times the square root of 5 is the square root of 25, which is 5. And then on the top, I end up with 3 times 5 is 15. And that can't be factored down. It's not a square. And there's no squares in it, right? 3 and 5 are not squares. All right, guys, for homework tonight, you're going to try a few of these problems. Page 631. We're going to do 17 through 41 odd so that you can check your answers. If you have any questions, I'm going to be on today, Google Hangouts 2:15 for about 45 minutes, so probably till 3. Let me know if you have any questions or if you just need to check in. I'll send you a link. Thanks, guys. Good luck.